Hello. Why are you here? That's an important question. We're going to cover that in a second. So just making sure you're in the right room and you haven't got your directions wrong. This is the Cosmos DB Designing and Troubleshooting Lessons double session. So we couldn't pack it in one. We're going to do a double session, which means we're going to run all the way to 6 o'clock. If you look in your app, it says 5:45 finish. That's incorrect. So it's a 75-minute session, a 15-minute break. You're going to need it. And then we're going to do another 75-minute session. A couple of housekeeping slides, I should say. Silence your cell phones, but if you don't, we'll get entertained when it goes off. You've probably seen this slide a few times already, but do explore what PASS has to offer. There's a ton of stuff out there. So go and speak to speakers, other people, go to the website. There's literally a ton of stuff out there, including previous recordings from previous PASS sessions that you can actually access as well. So going back to my first question, why are you here? Well, you're probably going to be covering one or more of these pillars. You're going to be looking at learning. You're going to be trying to find out more about a specific product, technology, skill sets, some way of kind of doing something different than your way of doing today. And you're probably going to try and get a bit more knowledge than you have on one of those technologies. And Cosmos DB may be a brand new technology to you. Networking. This is really important, and one of the things that I found over the years definitely made a big difference to me was figuring out who to talk to, having a chat with them, figuring out what their challenges were themselves, finding that I had similar challenges, and being able to connect. Facebook, Twitter, LinkedIn, standard emails, and also mail through posts as well. But you're going to have some fun, and actually we have an event right after, at the end of today, that a load of my friends are coming to. It's around whiskey, but it's going to be great networking capabilities as well. And there's a bunch of exhibitors that make this possible to be here, as well as you guys coming along. So go and see what they have. Microsoft have launched an absolute massive amount of new changes at Unite and also at the keynotes here about SQL Server Release 2019 and all the new features and capabilities in a whole raft of different products. Why are you here for this session? Good question. Why are you here? So you're probably going to figure out what Cosmos DB is. Hopefully, I'll be able to educate a little bit around that. You will probably look to take away something specific to your own self, and that might be different to the person sitting next to you. And what I was going to say is actually shake hands with the next person, but that's going to prove difficult, I think. So we'll skip that piece. But you've probably got a bunch of different reasons to be here. So we're going to see what we can cover in the next couple of hours in terms of content. If you have questions, throw this hand up, and I'll try and get to you. Some of you guys are a bit further away, and I'm actually deaf on one side. So if you start talking, I have to do this find the sound competition for myself to work out who was actually talking. So if you throw your hand up, I'll be able to answer a lot easier when I find you. Okay, we've got 2.5 hours. First 75-minute session, a bit of a break, 75-minute session, and then we're going to go into what we have. Why am I up here? Good question. I've been asking that all day long, actually, before I came over. I'm a SQL Server data professional. I've been working with SQL Server and data platform technologies for a long time. And I got into the NoSQL technologies through my consulting that I do. I have my own practice. We're a gold data analytics practice from Microsoft, a learning provider. I'm an MCT. I kind of go out there and do this regularly. So I deliver one-day workshops for Cosmos DB. I deliver multi-day courses. And I do a bit of consulting as well. But if you want to get hold of me, Neil_Hambly on Twitter. There's 3,500 other people that feel that they want to follow me. And you can just email me as well. I have a bunch of business cards if you have questions. So grab one at some point, and I'm happy to answer questions. That's my website. We'll carry on. So session 1, this session, we're going to be covering a quick introduction to Cosmos DB. What is it all about? Why do we want to use this technology, and what's its kind of benefits over maybe a relational database? We're going to look at optimizing your Cosmos DB solution by considering a key topic called partitioning. We'll look at why we do that, what its benefits are and how we get it right. Because you can easily get it wrong, and that might cost you not only from a performance standpoint, but from a cost standpoint. I've had a customer recently that had to open up the gate at Microsoft in order to get their performance throughput because they chose the wrong partitioning key and they needed to do something differently, but they couldn't change it straight away. And they had to go from 30,000 to 400,000 RUs. That's a serious amount of bucks. That's like probably a couple of cars a day cost in terms of that. But then they'd be able to change their partitioning and get it to the right structure, and then their costs came dramatically down. After that, we're going to look at querying the database using one of the APIs. And we're going to look at what the different APIs exist and why we can have different ones and why that's beneficial and why you have a mix maybe of different types of models inside of your Cosmos DB environment. After the break, we got a bit more work to do. We're going to look at performance tuning and how we kind of get that more optimized for our systems, not only from performance, but a lower cost of ownership. So getting those RUs, request units, right down to a much better level. And how do you measure that, and how do you make these tweaks to the system? And then finally, we're not going to cover everything you need to know, so there's a whole bunch of training resources that we're actually going to kind of give you a place of going to learn a bit afterwards. And this is all freely available, so you can go and grab this information. Okay. Intro. Normally I kind of do a hands up who's done this and stuff, but you know, to be honest, I'll be looking as I can't see anyone at the moment. There's a few more people this side. Partitioning is not working very well for me. That's partitioned better. This one's okay. This one's very sparse. So we haven't got a good partition strategy, but if you haven't used Cosmos DB, I'm going to do a quick run through. I'm not going to spend a great deal of time on the intro, but you'll kind of get the feel for it as you go through anyway. So, intro. What is Cosmos DB? Well, it's the Microsoft's offering of NoSQL. This kind of unstructured data set, which actually is the majority of data out in the world today, is in an unstructured format. So about 70–80% of all data produced comes in that format. So we need a system that is able to cope with those kind of no-structured structures and put them in and have schemas applied at a later runtime. So what we have, if you can see from the slides on there, is a couple of things that are key to this deployment from Microsoft. One is it's a multi-model deployment, which means we can choose one of 5 different models for our deployment. And we may have one that is a SQL or core API model that we want to use with an API that sits behind that. We may have a Cassandra or MongoDB implementation. We might have a table version, and we may have a graph version as well. We can choose one or more of these databases inside of our account. So we create an account, we create databases, and inside those databases, we define what structure that's going to be. And then we build a bunch of collections that's going to store the data. And then we're going to query that data, process it, and do a whole great deal of more stuff. I'm going to go through some of that now for you. So these are the different models that we have that exist inside of Cosmos DB. Because we may have data that's more of a node and graph edge type data set. We understand the vertices and how they're related. We may have more columnar type data with Cassandra. So there's a bunch of different ones, and we go through, we can revision this, and we can add multiples. We can have a Cassandra one, we can have a SQL one, we can have a graph one. We can choose to have more than one. And on top of that, we can talk to our Cosmos DB accounts and our databases with different languages. And we can use the one that's more relevant to what we do. And actually, we can have crossover between different APIs that we're going to call and the language and the database we're going to actually provision. Okay. I didn't draw these, but these are very cool ways of understanding at a high level what Cosmos DB is doing. And they're called Cosmic Notes. And don't worry, in the slide deck I have, all 85 of the current Cosmic Notes. I'm going to show you some of them. I'm going to describe some of those as we go through. But it's a great way of getting a high-level, quick concept of what's actually happening. and being able to kind of just take some great information very quickly. And here's what we call the resource model. And what it is the data starts off in, number one, an account. If you don't have a Cosmos DB account, you need to create one. Simple process. You're going to subscribe. We're going to show you how to do it through code and through the portal. Once we have the account, which is essentially a way of working out who's going to get charged for it, and we have subscriptions, etc., that are bound to that, we have to create our databases. And this is where we create the different version of our database. Depends on what type of data we're going to store in there. Once we have a database, we want to have one or more collections, as are known. And these are essentially logical units that we're going to use to store data that we want to then kind of, hey, this is maybe our sales data, this is maybe my budget data. And they may have different types of data schemas, essentially, we want to apply later on, and we can mix and match what we store in those. And depends on the database type you go with, you may have a document, you may have a node, you may have a row, etc. And it's going to depend on what you're actually provisioning here. The second thing you're going to need to do is say how much of it you want to be prepared to pay for. So we start off with a really small $24 a month provision with what we call the request unit size of 400, which is the minimum size you can currently set your database to. But it's scalable, which means I can move that cursor to the right-hand side on the portal or through code and actually provision that up to, at the moment, the largest you can do without speaking to Microsoft is 30,000. And we got some calculators. I'm going to show you some stuff on how we calculate how much this thing costs and how to track that and how to put limits on it. But what essentially it's doing, it's saying how many operations do I want to do within a second, and a read or write operation. An update is essentially a combination of those operations types. And there may be a stored procedure running, there may be a trigger as well, there may be a UDF. But essentially, under the covers, at the end of the day, what we're doing is we're saying, read 1 kilobyte document in 1 second costs 1 RU. That's our measurement. It's essentially CPU, I/O, and some other metrics internally that essentially is going to say, right, here's what's going to cost when I do this operation. To write 1K document, it's about 5 RU. It may vary a little bit to that, but 1 to read, 5 to write. And the size of the document is important. And this will come back to later on of how you do your document structures, whether it's embedded or referenced, and how big the document is and how much data you're processing. So this is the size of data operation, essentially, as I know it and call it. And we have a couple of options here. We can put it provisioned at the database level, so all the collections that exist under that can share that 1 RU provisioned, or we can do it at the container or collection level, where we say this collection or container has 400 or 1,000 or 20,000 RUs. But we can make that scale go up and down as well within the limits. If you're going to go above 30,000, you will need to speak to Microsoft and say, yeah, I want to spend a bit more money, and they will gladly do it. Up until the size the data center can handle. And I had one client max out a data center for Microsoft. We figured out how to fix that, but yeah, it can get quite big and messy. So we want to work out if we're provisioning at database level or the individual collections that we have. That's for a single data center. But this is a geographically distributed database, which means we can have data in local areas closer to where our customers are to get that latency performance that we need. Cosmos DB is designed to be a multi or a single digit millisecond response for reads or writes guaranteed from the engine. But if you're then halfway across the world, you have a speed of light problem. You'll need to encounter for that extra kind of processing time to move it from one side of the world to the other, maybe 400 milliseconds. But once we also have that, there's another thing we need to take care of is what we call consistency levels. Now, most of the NoSQL systems out there have two, eventual and strong. And you can choose one or the other. And that depends on when the data gets updated and when you see it, and how quickly you're going to see it. Cosmos DB has 5. The ones that we have are strong. We have bounded staleness. We have session, which is the default, and you pretty much most of the deployments out there, about 97 or plus, actually use the session consistency level. We have consistent prefix or prefix consistent, and then we have the eventual. And I'll show you in the portal how you can understand the differential between when data gets updated and what order and what the implications are. But generally, you will go probably with session unless you change that default. And I'll show you where you can do that. And I've got a few more slides here, but I'm going to skip through some of these to kind of get through to the core stuff. Okay. But it's in the slide deck so you have that availability to download the whole slide deck and see everything that I've got in here. Okay. How much does it cost? Well, if you were listening earlier and paying attention, you may have heard I said request units and its provision level. That was up until Monday when they decided to announce a new storage engine capability inside of Cosmos DB. And we've got a new analytics engine as well as our transactional engine. The transactional engine uses RUs that you provision, so a 400, a 600, 1,000, 20,000. There's a cost for that, and I'm going to show you what that is. The analytics engine does not use the provisioned RUs. It uses a throughput cost based on the amount of 10,000 blocks of reads or writes you're doing. Okay, and that's roughly, I think, 0.002 of a dollar per so many of these operations. You can kind of work out what those numbers are. But we have now an analytics engine, which is essentially Parquet files under the covers that we can connect our Synapse analytics to it and our Spark engines to it and do a bunch of stuff. But I'm not going to cover that in this session. I'm covering the transactional engine. But I have a few what's new slides to show you in a second. But there's a great little capacity planner that helps you with this. And I'm just going to jump over to my screen to show you this now. But the decks are there as well. Let me just jump out of this one. Jump over to here. And I think if I go to my capacity planner, you should see it here. Let me just zoom in and make sure you can kind of see a little bit of stuff there. So it's cosmos.azure.com capacity planner. And essentially, or calculator, I should say, sorry. And we can define how many regions we want, what's the size of the document, how many reads and writes per second. So what I've got is a quick example of that. And here, if I just change some of these numbers, so I'm going to put 1,000 into my calculator here, and it's recalculating the cost in the bottom right corner, you'll see, of what it's going to roughly cost. Now, you get charged per hour, so whatever kind of was the highest RUs in that 1 hour segment is what you're going to charge. So if you just spin something up and run it for 10 seconds, you get charged for 1 hour. So be aware of that. If you're doing testing and doing other stuff, you don't necessarily need to use the service. You can use an emulator that we can download. It's free, but it doesn't really test things at scale and globally. It gives you more a way of testing your code and your execution of stuff. But this is what we're going to basically cost our usage on with 2 locations, so one in East US, one in West US, and the number of operations here. Okay, let me jump back there. So we've got that capacity planner. No, where was I? From current slide, there we go. Okay, so we have our billing model that tells you roughly what the costs are involved. Essentially, you're paying for storage, which is SSD behind the covers, and you're paying through your provision throughput. Okay, enough said on that. And there is a way inside the portal to click into the portal itself and look at your collections, look at what you're spending and what your current provisioned RUs are. So we'll show you that later as well. But there's also one of the things that I often get told is like, so Cosmos, that's slow and expensive, isn't it? It is if you do it wrong. And it can be. but you can also do it right, and also you can buy what's called reserved capacity, which is generally roughly about 2/3 of the actual cost of running it as a go kind of, so like you're contracting your phone, pay as you go, you're going to be charging a nice pricing for that. But if you kind of sign up for a contract, you're going to get a much cheaper pricing. This is what we do here with the reserve capacity. Okay. How do we work with Cosmos DB? Well, we've probably got a couple of different tools. One of those is an Azure product. So we basically probably were using the Azure portal, or there's something called the Cosmos DB Explorer or Data Explorer. And we can basically go to that and log into our account and connect to the database of choice and the collection and run our queries here. So this is a quick example of what that looks like. And what happens, it strips away a load of the infrastructure from Azure, so you're just kind of working with a much larger real estate here. But here we're showing we've got a specific database called Wingtips. In there's a customer tickets collection. And in there, documents or items, it might also be referred to, is the specific documents we have. And you may have 20 documents in there. You could have, some of my customers have 300 or 400 million documents in some of their collections, okay, or more. And I think some of the demos I've seen from Microsoft have like a petabyte of data and, a trillion documents, something like that. It's pretty much unlimited. You'll just pay for what you use in terms of storage, and you'll pay for what you use in terms of provisioning. Okay. If you want to test stuff out, make sure you use the emulator, so you're not going to consume resources up in the Azure space and spend money you don't need to. This is a useful way of getting additional costs here, okay, reduced. There's a whole number of slides here about overview, value proposition, etc. I'm going to hit a couple of them, but they're in the slide deck and you'll be able to look at them later on. But I'm just going to hit a couple of them first off. It's very elastic, very scalable. So how many documents you need now, tomorrow, you may not know those answers, but when you do need them, you can scale this thing, and it's geographically represented, so I can put it in multiple data centers very quickly. It's actually what we call a turnkey deployment. I can just click a couple of buttons, and it's deployed. I'll reach for the water. I'm back on. This was, by the way, was an evolution of Document DB as a product. We have guaranteed low latency, SLAs that are driven behind this of a single-digit millisecond response. On average, your reads will be between 1 and 3 milliseconds. Your writes will be between 3 and maybe 5 or 6 milliseconds on average, at whatever performance levels of ingestion you want that to be. So 10 documents, sure. 10,000 documents, okay. 10 million documents, we'll do that as well. You're going to have to pay for it, but we can ingest those numbers. And we do that by partitioning the data strategies. And we're going to go through partitioning in a second. But we can get that guaranteed performance, so you never lose that transaction. It's never going to time out and the customer's going to walk away because they didn't have enough time. Click it, it's done. We have fully indexed by default on. Every piece of document that comes in is indexed. Now we can play with that a little bit and improve some of our performance characteristics and costs. But think about how difficult indexing has been in traditional relational engines. It's been a big thing you've had to take care of. This is on by default, and it indexes every document as it comes in. As I said, turnkey, you will literally show an example where I click on a couple of different buttons and I bring up some additional data centers. I think we can do like 10 terabytes within an hour into a new zone anywhere in the world. So 10 terabytes of data. Click on a button, within an hour it's going to be fully provisioned in another data center. Under the covers, replication is all handled for you. You've got no complexity you need to take care of. They do it for you. They take care of that. And that allows you to have 4 nines with a single region and 5 nines when you go to multi-region. And that's not just for reads. You can turn on multi-master writes as well. So I can write into multi-regions and have it take care of all of the kind of underlying plumbing that I need. We've got our 5 consistency models I explained earlier. And we will have all these different APIs we can make use of. Say, most of these are in here because I teach this as a class and a workshop. So I've kind of taken some of the key bits out and just showing you that for now. But essentially, any data with any structures, you can put those in, and they're basically JSON files. So that's JavaScript object notation type documents. And what we're going to do is basically ingest those. They're fully indexed. We can do some additional indexing and partitioning structures on that to make things performance. But what we're going to end up with is a very, very fast database. You may or may not know that pretty much Azure runs on this stuff. Most of Azure that you're running today, that's Cosmos DB under the covers. Microsoft used it for multiple years, 6 or 7 or 8 years or more, before they released it as a product. Okay? So this has only come into kind of a product version that you can consume in the last few years. And they're going to do a lot of different changes and improvements. We have a question. This could be interesting. Let me come a bit closer, because I am really deaf, by the way, so if you can say it a bit louder. Okay, so the question, if I heard it correctly, is for each of the geographically regions, like West US, West US, for example, can I change the RU levels? Yes, you can. Okay, so you can define the collection level that you're doing and where that is. So, for example, you might have a backup one. One's got 10,000, one's got 1,000, because you don't really use that. You haven't got that many customers there. Okay, so we can define that. But we're defining that the document database itself, or Cosmos DB, is going to keep all the data in replicated formats. Okay, but you can kind of tune the levels for us. Okay. We got our SLAs, so that's good. And we're basically talking about the 99th percentile there, and the SLAs are 99.994 for single and et cetera. So basically, if they don't hit those SLAs, if you do have something that doesn't hit what it should be, they will take some money, give some money back to you for that failure. But it's designed to be extremely fast. I'm going to click through a bunch of these ones here. I'm not going to go through a load of these, but these are the 10 top reasons why Cosmos DB is why customers choose it. I'll let you read the screen for a couple of seconds. I won't go through all the items there. But essentially, it's highly flexible, highly scalable, and it can be a very low-cost option for the. And now with the analytics engine that's come in with Synapse Analytics, we'll have the ability to do a no ETL, i.e. we don't need to do ETL of that data anywhere else, and do analytics within a 30-second time frame. We will have that data in our analytics engine and perform queries on it. And machine learning and AI and deep learning and the rest. Okay, so it's kind of bringing together a bunch of other capabilities with maybe like a real-time feed using Azure Cosmos DB as your back end, streaming that data in, doing analytics and stuff like personalization for your shopping and a whole bunch of examples. This is an example of peak sales. So, scalability during a Monday on February. We probably don't have too many sales compared to a Black Friday. But we need to provision our resourcing so that when we do have that Black Friday, we can do the data processing effectively. But then we scale back down to just a much lower level when we don't need that high throughput. There's a ton of examples here. It goes through more. ASOS was a company I did some work for, and they have a hot and a cold pathway evaluating. Also, when you're scanning that website and doing some actual processing, purchasing, they're actually going to give you a hot recommendation. Oh, you might want to buy this with those shoes, that kind of stuff. Gaming's a big one. I'm not a gamer, although I have a gaming laptop. It's like, do you play games? No. I just like the spec, it's good. But these are things where globally you have multiplayer systems and you want to be able to kind of have those work. You need performance, you need that latency to be blindingly fast. Okay. And there's a ton more finance and et cetera. It all gets boring at this point. It's like, but these are what we're trying to solve from a kind of specific needs. And these different industries and different products and different kind of systems need different things. But Cosmos DB is able to provide that scale, that performance, that security, compliance, all those fines. Okay. And there's some top 20 kind of use cases there. Okay. At Ignite, we had some big announcements. I'm going to cherry pick a couple of them for you. So the first one was we didn't have group by support. So our analytics queries were basically difficult to do. We had to maybe do some analytics, prove out to the analytics engine somewhere else to do that. We can now do that here, and aggregations has improved as well in terms of performance. But we have the ability now to kind of just do our T-SQL group by. Basically on data that comes in at streaming capacity, millions of documents per minute, maybe, thousands and tens of thousands per second, and actually run on queries over that and guaranteed less than 10 millisecond latency. There was also something else which is massive. Before, you had to kind of control the number of RUs yourself, and you had to go in and maybe you had a function in Azure that kind of tried to track it and kind of do that. Now when you provision, instead of choosing the RU level, you can choose an autopilot. It's in preview, so beware of that. But basically you can then choose to have it registered, and then when it's registered, what you do is then you go and say, okay, I want 4,000 as my max level, or 20,000 as my max level. And you're choosing the maximum level, and I think they've got 4 or 5 different levels. Only came out Monday, so I haven't had a chance to play. I tried to, and I'll show you, I tried to turn on the analytics engine. The autopilot came on registered within like 10 seconds. The analytics engine has been trying to register for 3 days now. And I've tried it on a few different ones, and it's not playing. So there's something not quite working yet. So be aware of that. There's a quick group by with some advanced query information here. So I've got some arrays in there. I'm doing some tag metadata processing. But now I can do my complicated queries in place inside that engine without having to do any ETL, which is going to reduce my costs dramatically, and my performance can be done. I've got my query straight away. I haven't got to move the data and then do my query. There's a few more. The one I probably spoke about a couple of times now was Synapse analytics integration, which is the analytics engine that's now alongside the transactional engine. There's no extra cost for that, but essentially you can even get to the point where you would maybe turn off the RU cost by doing a -1 on your TTL, for example, and actually just have it as an analytics engine and just going to be able to do your queries later on when you need it. So that's going to be a cool thing to be able to do. Here's some of the autopilot stuff and the Synapse integration preview, showing you the new kind of, hashed in gray color analytics engine. And there's some additional kind of things about how this differs between one engine and the next, etc. I've got a few slides of that information there as well. And who's heard of Jupyter notebooks? If you haven't, you've been asleep, because everyone's talking about them. Every session I go into, they've got Jupyter Notebook up. We now have integration built into Cosmos DB for Jupyter Notebooks. Absolutely awesome that we can kind of do the notebook stuff and run our queries again using notebooks and the capabilities that come with that directly against our Cosmos DB, etc. Again, don't have too much time to go into the details, but this is going to be huge. Reason why probably it's going to become much more popular as a product. And you can do like, in-place virtualization and visualization, rather, I should say, of your data using a ton of different capabilities like Interact and Python scripts and Scala and R and whatever T-SQL language you want to throw at it, and you can do a whole bunch of stuff with essentially any of the packages that are out there. Okay. That went over by about 2 minutes, so I'm going to have to get on with it. Okay, partitioning. Cosmos DB needs to be, like anything, designed for the best performance. And one of the key things you're going to need to work out straight up front, and probably the most important decision, is how do I partition this thing? And you're probably going to try a few different strategies to work out what that is and establish what the RU cost of your most commonly used queries are. So with traditional relational engine, you're going to essentially know the structure and build out those structures, and they're related, and everything's good. Cosmos DB, you basically kind of come from the other side and say, what's the most common queries I'm going to run against this thing? And let's make that the most cost-effective way of doing things. We might have the odd query here and there that is complicated and expensive, fine. But if 80 or more, 20%, the 80-20 rule, 80% of my queries are these 3 or 4 queries, I'm going to tune for that because I want to get that performance. So what does this look like? Oh, we got another one of those funky little diagrams. But essentially, what we're trying to show here is we're creating partitioning to create logical partitions. The more, the better. And you may even want to create a synthetic partition key to actually get your performance. But if you look at this, basically we're doing user ID, Thomas, Deborah, Andrew, etc. And what it's doing, it's then saying when that data comes in, Andrew goes in this partition, goes in this block. Deborah goes in this block. And what I need roughly is a fairly equal grouping of data across these partitions. What happens under the covers is it takes those logical partitions and it groups them into some physical partitions under the covers. You don't control that. Cosmos DB, Cosmos DB does that for you. And when one kind of gets a bit full, it moves some data around. It's like splitting an index, basically. What it allows us to do is scale horizontally to massive amount of data, guaranteeing the performance of what we're doing here. So, how do we do partitioning? We need to figure out what the key is that we need. So the first thing you're going to do is maybe understand a little bit about the data, what type of queries we're running, or we might want to log data about what queries are being run, so later on we might come back and improve that performance. But we know we're going to select these 4 columns from this collection, and we're doing some predicates. We're doing where this value equals or in a range or something like that. And that query is the kind of things that we're running over and over and over again, many thousands of times, maybe a second. That's great. That's a good one there. We can see here we have a bad one shown on the throughput on the right-hand side. What we have is what we call hotspots that might occur inside your data sets. When I talked about provisioning, I said what your RUs are. That's essentially on that physical partition. So if you have 4 logical partitions that's grouped in, that physical partition essentially has some CPU memory, I/O, networking, that kind of stuff, but it's got some physical resources. There's a logical limit of 10 gig currently for a logical partition. Now, what happens when you fill that up? It's going to do some internal kind of processing to split that. But essentially, you need to have really a fairly even, uniform distribution of your data across those logical partitions, being aware that your data size is important and the logical partition has a limit of 10 gig rather. Carry on. So how do we improve that? Well, we need to design our structures, not schema, but how we deploy the partitioning so that we get it done well. So let's think of like a website where you've got people posting some stuff like a Facebook, for example. They post it, and there's a bunch of people comment on it. Now, at the moment, in a traditional relation engine, you probably would have those separate into separate table entities with a relationship. In Cosmos DB, what we're probably going to do here is an example of actually probably having a post ID and actually co-locating the comments and the data, that original post, in the same partition, so that when you issue a query, it goes to a single partition. It's not doing what we call a fan out to across partitions. And there's a few things. We're going to go specifically into partition in a lot more detail in a second. But essentially, what we're finding is this data modeling needs to essentially be dictated by the access pattern, as we call it. How are we querying the data? Are we maximizing the write performance? Are we going to maximize the read performance? You know, there may be a trade-off a little bit between the two, but partition is going to be the key component to getting this right. And there's some references to other material, et cetera. I'm going to show you where you can go and get some more details about how to establish what's a good partition key. But ultimately, it comes down to you guys doing your homework. And I noticed right at the back, we have a question. You would have to sit at the back, wouldn't you? You're going to have to come forward because I would not hear you from back there, sir. So come forward, we'll answer the question. So are we still guaranteed the same latency with? Okay. Yes, from the latency perspective, no from a cost perspective. So it may be a very expensive query. You might go from 15 RUs for that query good in a good performance model to 1,500 RUs in a bad, okay? But the performance is guaranteed in terms of reads and writes. Okay. Thanks for sitting at the back and testing my hair. No, that's good. I did hear you, sir. Thank you for that. There's a few other slides in here. I'm going to skip through most of those there. And there's some guidance here as well. But there is an upper limit of 10 gig that you need to be aware of. And when you're doing your design, work out, well, if my documents are 20K in size, how many can I get in that logical partition for my 10 gig? And this comes into another design point of, do I embed or do I reference my documents? How big is my document and how is it split into the types of information here? And that we'll go into that a little bit later on when we look at troubleshooting. Okay. I've got a bunch of stuff again inside. There's 250 slides in this thing, by the way. So yeah, I've got 2 hours and we ain't going to get through 250. But it's in the slide deck if you need them. But essentially, I'm picking out some of the key ones here. You've got to provision for your RUs. This is what performance I'm expecting to be able to get for number of reads or writes per second. And this is kind of the cost of that, depends on the size of the document. As I said earlier, you can define that at the database or at the container level, or a combination of those. Take a little sip. Okay, let's quick in. So I'm going to go through, skip through a bunch of these here. Where do you set this up? Let's go and have a look. So first off, here's my demo account I've got kind of for this session. Clicking in there. And if I click the overview, you'll notice that we have a bunch of obviously typical Azure related information and it's all over the place. But what we want to do there is we want to go and work out what we're going to have in terms of performance characteristics. Okay, so there's a couple of things. First off, how many sites do I need it in? I'm going to click on this, and just so you can kind of see it churning in the background while we look at some of the other stuff. That's why I've come to this bit first. I have one region, West US 2. But you know what? I've opened a new office in the East Coast, and I now want to have data located over there for my customers that want to make purchases. So I'm going to add in an additional East Coast one. And if we just scroll down, there's another one here. Now, there is something also known, by the way, of paired locations. So certain locations have a pair somewhere else in that region that works with it nicely. And I think for West US too, it's East US. I've clicked on it. All I'm going to do is click the Save button. 2 clicks. Click on the one I want, click on Save. This is now, under the covers, actually going to provision. You can see it's making a bit of a noise about it. Provision that new data center up. That's the extent I need to do in terms of bringing on a new data center. I did this for one customer for 50 terabytes of data from Europe to the US. They went, is that all you need to do? I went, yeah, I'm going for coffee now. And within about an hour, we had it fully provisioned. It was about 2 hours, I think, total, what we had in the end. That was all it took. That's the turnkey representation there. So that will come over. That will eventually come in. That's for a read. Once I've got both of them provisions, I can then choose if I want them to both to be master writes. So at the moment, I've got a single write region, which will be the West US 2. I've added in East US. When that's provisioned, I can then decide whether it's going to be a write region as well. We'll come back to that. Okay. Where do I do my scale? Well, if we go down to the container section, we have our scale, settings, etc. I'm going to go and click on my scale. And this is where I get to choose for each one of the databases stroke collections that exist, what the rating needs to be. By the way, if you want to change the rating on a different location, you can't do it through the portal. There's a reason for that, and it's hard to explain, but you can do it, but you have to do it behind the covers and through code. But essentially what I have here is a provision level, 400, to unlimited. I like the unlimited bit. How much money you got? And when I mean how much money, I'm talking I could probably get you to spend a couple of £1 million a month for one data center, and you want to put it in 10 data centers. So you Bill Gates, maybe, I don't know. Not for long. We also have these settings, which I'm going to show you a little bit later on a bit about, called time to leave. You've got a big database. You may use the data for a while, but then you need to maybe purge it or archive it or do something with it later on. Time to live is a setting that we can deploy at a per collection and even a per document setting if needed to say, how long should it stay inside and alive in that database? If I set that for an hour, after an hour, it becomes inactive. Sometime later on, a background process will come around and get rid of it with no cost to your RUs. But if you go and delete that document through a delete process, it's going to cost you RUs. So there's a cost perspective about kind of using that setting value. It's off by default. You can put it on, and you can also do it. But the key bit that we're actually going to work out later on is this partitioning value and the indexing that we have in here as well. Okay, we'll come to that later on. But I'm spending loads of money. Currently, 2 regions is going to cost me 64.64 of a cent an hour. So $2.54, sorry, not pounds, dollars, $2.54 a month, daily. At the 400 level. Remember, that's assuming it's 400 for every single hour of the day. If I move that up and down at different levels during the day, I'm going to work out what the maximum is in that 1 hour time frame. And this is how I change it. I'm just going to add an order. I'm just going to 10x it, save. Okay. That's now just changed to a 4,000. That's the only way, that's my scale change, done. That will pretty much be fairly instantaneous behind the scenes. I want to know what I have. Let me click on Browse. Well, you notice I've got some shared ones, and I've got some 400 shared, and I've got a 4,000 now that I just basically did. and I can see what the costs are. I can also see how much storage I have, and I can work out my storage cost because that's a different separate cost. It's very low, but there will be some extra cost there. So this is how I work out what's going on, and this is how I scale things. Or if I'm in a code or application, what I can do is actually do that in code as well. And this one actually, I just updated this, so it's not the right one. But I was setting, when I did this earlier, I set it to a 10,000. So when I do it in code, I can actually define the RU level. I provision this stuff out as well. I won't go into all the details of the code. There is a full set of labs around how to do all of this in, if I can find it, this workshop here. So if you want to start playing with the Cosmos DB and work out how to do things and do these code examples, there's a whole bunch of labs there you can actually work through yourself to get a better familiarity with the product, maybe before you go and start work for it in a real kind of world scenario. This is a 2-day course. But we go through all of the content. Pretty much what you're doing in this, and all the decks you have in here and all the slides have most of what's in here. But I reference this as well, so you've got additional materials. By the way, if you're looking for those Cosmic notes, these are all the Cosmic. There's 85 of them, I think. Again, they're all in the deck. And I did get permission from the owners of Cosmic Notes to put them into the deck, so they were very happy we were going to do that. But I said, look, I'll showcase your fantastic resource information. Okay, let's look where we are time-wise. Okay, so we're about 25 minutes before the break, which is roughly where we were. So let me go back to from current slide. So there's a ton of more slides in here about request units, but you get the principle of it. You pay for what you're going to provision, not for what you use. So think about it from a car perspective. I'm going to hire that car. I'm paying a per day charge for hiring it. I'm not paying per the miles I'm using, unless you have a different car hire company than I have. I pay for how many days I need it for and how big a faster car I want. Okay, so there's a ton of these. I'm just going to skip through most of those. There's one towards the end that is actually estimated and then kind of doing your calculations. So you want to understand how many times am I going to write to this thing? How many times am I going to read? What's my throughput in terms of numbers? And then I need to do some bit of maths, and this is where the capacity helps with that kind of number of documents. What RUs do I need? If I went back to that one very quickly, you'll notice when I had that one up here, I had my workload per region. Oops, wrong one. Let me try that again. 100 gig of data, but 1,000 RAIDs and essentially a smaller number of writes per region. And that then got calculated into, I wanted 20,000 roughly, so I'm going to look at 20,000 RUs. That's what I need to provision. If I'm going to do my new version with the pilots, I'm going to have to say this is the max capacity I want and let Azure figure out the volumes of resourcing dynamically as and when it needs it. Question? Sorry. Yep. Yep. Brilliant question. Thank you very much. The question is, I'm provisioning for a certain capacity. What happens when I hit those kind of capacity limits? Well, what will happen is two things. One, potentially it could, what we call rate limit you. So you may get a few more extra request units. You can kind of do some benchmarking. Essentially, it should roughly level down to what you paid for. But you may get rate limited, which is an error code 429. And you can actually see that in the portal and track for it. And what happens is when it rate limits you, it comes back within the header information, says, you need to wait this amount of time before trying that again. And it provides information back through code to say, this is what you're having. But potentially what could happen is it could just deny the query. And essentially you're going to have some retry logic to kind of go and do some stuff. But the autopilot I was just talking about, if you were doing that, when you get to those limits, it goes, oh, you need a little bit more. And it pushes the limit up and brings it back down when you don't need as many, and goes back up again and comes back down. So you're going to get a flexible resourcing based with a max capacity that you set. So it starts at 4,000, I think it goes in 4,000 increments. That would be kind of, okay, this is the max I can go to. I can scale up and I'll scale down. And it's basically going to kind of track the performance needs that it has, based on some metrics I have no understanding of at the moment because it just got announced. So I haven't had a chance to play with that one yet. But yeah, you might get rate limited. Question? Sorry, can you repeat that last bit again because I did miss it?
So like with most of the auto-scaling solutions in cloud, you see a latency when it auto-scales, which is essentially what the autopilot is just scaling up and down and
So so the question is, there's some code out there, some examples where, and actually I built some myself, auto-scaling. What you do is you get an Azure function that tracks the resource usage, the RUs that are being used, etc. When they get close to limits, you actually request an extra piece of RU. Okay, I need an extra 200 RUs or 1,000 RUs. And that will pretty much be instantaneous, the changes. So you've got some code that's constantly monitoring some metrics. That essentially then you go, oh, actually, I'm going to need a bit more because I think I've got... Now, I won't know how many documents are going to flow in behind it, but because I got close, it's pushed the limit. I get close, it pushes the limit. At some point later on, it's going to track back down again. It's going to be like snowfall coming back down. But then at some point, it's going to go back up. So you may have some code like Azure functions that do that auto-tracking. This autopilot is essentially doing that for you. It's providing that capability, okay? Did that answer the question? There you go. If you didn't fully answer the question, come and see afterwards. It's hard with my hearing to actually kind of understand it. It's quite echoey in here as well. Okay. Where are we? So we've got another 18 minutes, okay. Okay. There's some additional things that I want to make you aware of is something called the change feed. And what change feed does is basically says for this partition, so partition is important, for this partition, track every single change that comes in the order it happens per partition. And what we're allowed to do with some functions or other capabilities is to take those changes and do something else. One of those I've used in a lot of cases is actually to take a copy of the document as it gets changed and to move that somewhere else for maybe analytics or maybe for an archiving. As it arrives the first time, I'm going to take that and put it into another store that has no indexing on it, so it's really cheap and inexpensive with a very low RU cost. But I've got that with a time to live, I should say, of 5 years because of compliance. It's basically a store. But my active database, my transactional one I'm using, maybe I'm going to keep it there with a 30-day time to live on it. So we have these strategies that we can deploy. Okay, the change feed is a library, or the change feed library is something you can invoke that actually does all of the kind of nuances of plumbing around kind of moving stuff, and you basically just bind a function to it. It's very simple to do. There's a bunch of different examples. But here I'm going to show you one that we actually do pretty much near real-time updates using that function. Cosmos DB comes in. We've got this function, and essentially we're going to move that data and actually perform real-time analytics, maybe into Power BI or something else, possibly a screen on your wall at the office of actually what's actually occurring real time in terms of information. Maybe it's to do with the traffic systems you have. Maybe it's to do with security in terms of transactions that are going through your accounting system. So fraud detection. It's being used for those type of processes already. Okay. So some examples there. I won't go through all because we just don't have time. Normally I'd sit down, it's taking me about an hour. I'll show you the full example and we'll go through. I'm around tomorrow if you want to see this. I will go through this step by step and happy to sit and find a space to do that for you. Essentially what we're doing is bring a bunch of different information in and being able to kind of build the images, bring the processing through, do the analytics we need, and essentially materialize the data in Cosmos DB. So essentially we create these perspectives that move as time processes. And we call it materialized views. And we use the change feed to provide that perspective of what's happened in the last, say, 2-hour window as we move forward. I can come back and show you that in more detail. Okay. If you're not aware, there's a bunch of documentation in the Microsoft Docs around Cosmos DB. I'm going to show you some examples of that. Essentially, if you want to figure out how to do things, like with the change feed, and how to configure the triggers and everything else, it's pretty much there for you, okay? I have some workshops as well that kind of I can give you information to, but you can pretty much do this very, very easily as well. So we're going to look at maybe an example after the break as well around this. But we can kind of do that fairly easy. And we also can take our data and log it. And now, because this is a type of platform as a service tool, not an infrastructure as a service, we can log it into certain analytic workspaces. And we can do analytics on it. It's not we can't log everything, but there's some certain limitations around the logging we can do. But we can do and troubleshoot a whole bunch of stuff very, very easily and get our shared throughput or work out whether the throughput we have defined is a good one. And we can log some information and then perform metric analytics on that to understand what's our usage patterns, what time of day do we have different characteristics of data. Because we're logging that information and we're using the change feed and logs to provide that level of information. Okay, let's come back here. Click from current slide. Okay, so there's a bunch of slides about kind of how you do the provisioning, how you do kind of some analytics on that, how you work out your pricing costs, and you can use the product. I've got a whole bunch of change feed stuff in here, but again, you don't need to. We kind of covered most of this. But essentially, it can be used for multiple purposes, okay? So just be aware that we can use that tracking process. It's like a transactional log in SQL. You can read that with FNDB log, and we can kind of perform that kind of operational stuff, and we can get that understanding. This is essentially what we're doing, but we just have that capability about consuming the change feed. And okay, I'll come back to that one. So that was the materialized view example. There's a whole bunch of more slides around change feeds and scenarios that you might want to do. But essentially, we're pipeline. We have a question here. Does it consume any RUs? The answer is complicated, but yes, to some degree. But essentially, you're not really consuming RUs by having the change feed in place. But essentially, when you query the change feed, you're going to have some cost involved. So I have to explain and sit down and show you kind of where that comes from. But there is some cost associated with it because you will be querying the engine at some point for, I want that document. So there's going to be a read operation. But the change feed itself, by itself, doesn't actually invoke that. It's when you kind of use the change feed to go and get a document, for example, then there'd be a cost, okay? Question? So where's it, sorry, it was a replication between data centers, did you say? What was the first part of the question? I'm going to have to say, can you come a bit closer, because I'm not getting all the question.
What is the mechanism to replicate?
Oh, mechanism, sorry. Okay, thank you very much. So the question is, what's the mechanism? Under the covers, it's something that they won't really tell you exactly how they do it, but they're basically some blocks that are in Azure and like blob storage, and then moving those and replicating those. So it's basically the same kind of replication technology when they do replicas for your Azure storage. It's a similar thing, and basically they're kind of making use of that technology to a degree. They won't tell us exactly how they're doing it, but essentially that's Azure storage, and it's SSDs that it's stored on. So it's going to come into storage across to the SSD, so that's why it's really fast and quick. But essentially, it's block processing of replication like it does between Azure storage in different regions. Okay. Sorry, that answer was not great. Okay, so there's a whole bunch of kind of scenarios that we might want to use it for. There is something called potentially a lease collection, which is coming back to your example of what does it cost, because you may need a separate collection for your leases for the change feed, and there will be a minimum 400 for that. And that's probably going to be the size you'll need it for, unless you have a lot of leases, okay? So, you know, this is an example of kind of what's happening behind the scenes with the processor library, the leases, etc., how it all works. I haven't got time to go into details. Okay, so we've got about 7 or 8 minutes left before the break. So if you have gone to sleep, this is the time to wake up. But essentially, these are the things we're trying to do. Do I denormalize or normalize? Do I embed or reference? There's some design decisions that we need to make around Cosmos DB, okay? Putting the same data types in a collection, or do I move them into separate ones? So like in SQL, you kind of separate your data types out into different columns and stuff. With Cosmos DB, it's a JSON document that essentially can have different properties for every single document. This one's got a bunch of core data, and then it's got a bunch of reference information, maybe about their addresses and the siblings and everything else that might exist for the families, if that was the collection we had. But this one here is just his name and address, because he doesn't have any children. And that one over there, the next document, is actually about the cats. But potentially what I might do is actually have it reference where I keep all that family information in a single document, or I could have it where I'm embedding, so I'm kind of having the ability to put my collections like the cats into that same document. So it depends on the frequency of updates and changes to the documents and the amount of reads you're going to do. So if I've got a 1K document, it's going to cost me 1 RU. If that document is 5K in size, it's going to cost me 5 RUs to read it. But if I can take 4 of that RK and put it to one side, because I don't read it very often, then I'm mainly reading that 1K most of the time. Occasionally, I'm going to go and read the 4K. So it makes sense to go reference in there. But embedded means I might kind of want to always have that information in it. Maybe, to use an example, a menu, a recipe. The instructions of how to do it and the ingredients need to really be in one pull. So I'm going to embed that. The ingredients is going to be embedded along with the instructions, because otherwise I'm doing multiple reads. Go get me the instructions, and go get me the ingredients. So there may be reasons why you want to do one versus the other, that kind of stuff. Okay, so the modeling challenges, I'm going to go through this very quickly. But essentially, what kind of format do I want to do this in? And that may make a big decision on the volume of, or the RU cost overall, because of the size of the document. Okay. So it goes through the embedded versus the referencing design decisions that you want to make. My suggestion, try both. Try embedded, try referencing, try a few different examples, look at your queries, and understand what the RU cost is. I'm going to show you how to measure that after the break in more detail. There's some scenarios where you want to do embed. Data from entities is essentially always queried together. Recipe, instructions, ingredients. Some things dependent. The children dependent on the parent. I want to kind of get the family information. It's always a one-to-one relationship. So there's always a reason why that data goes with that, and it's paired, essentially. Similar rate of updates, etc. Here's the reasons why you want to do embedded. And reference will be this version. Again, I'm not going to go through all the details. We just literally don't have time. But essentially, summary. But like anything, ta-da, we can do both. So you can pick and choose. Most of your documents might be embedded. You might have some references. Doesn't mean you have to stick to one. You have some documents embedded, some references. Pick and choose. It's like Quality Street. Everyone doesn't like the little toffees at the end. I love those toffees. But you get to choose what you want here, okay? Okay. Cosmos DB, what goes into my Cosmos DB? Is it one entity per collection? Is it multiple entities per collection? Figure out what your access pattern is. That's the piece of information you need to take away, because that's the piece that drives the design that you're going to use, okay? Joins, essentially think of your embedded, I can kind of self-join inside the document. I've got my embedded kind of node of information, and I'm joining one to the other. So there's some examples where you can kind of see that being utilized. I can put an additional thing like a type property in that might help with understanding when I'm querying, type me for person. I want all documents that are person type. Or actually type me for the property like cat or dog. And in fact, actually, it might be, I'm then classifying that as a pet. Okay, so you've got these kind of scenarios. There's a bunch of more documents, scenarios in here. I'm going to skip through most of these now. But they're in here to help you with that. Okay, thank you. There's something called range indexes as well. Remember, we index everything. But actually, like SQL and other relational database engines, indexing is there to make things go faster. So we put things like in memory and column store and do all that. Essentially, indexing on here is a little bit more restrictive than you might think it might be. If your index is ascending, if you try and do a descending query, in SQL, that works fine. It just does a reverse range lookup. It doesn't work here. You won't get the index being used. It can be an expensive query, okay? So equality range queries, etc. You're going to need to look at your results and see if you use the index. Okay, we can create additional indexes. We can create composite indexes. We can decide what we need to do, but essentially look at your main queries and go, yeah, this is what I need to index. Remember, it may be an expensive query. It's going to come fast, but it just may cost you a lot of money to get it. Okay. So you need to kind of understand your costs as opposed to your performance there. Okay, last couple of minutes, because you may disappear and I may never see you again. I'm just going to summarize for 2 minutes what we have. Cosmos DB is Microsoft NoSQL database. You need to design for performance and design for your essentially throughput capabilities. You need to look at your documents and understand what you need to do that. Do you want to change your indexing policy to be a little bit less than everything? That would maybe reduce your cost, but if you then later on try and run a query against a non-indexed property, you're going to maybe find a very expensive query, okay? And the time could go high. You're guaranteed to get 1K performance, 1 RU rather, for 1K document if it's indexed. If you then keep going a non-indexed property, all bets are off, okay? We have ways of doing it through code, through the portal to actually revision this stuff up. And it's fully scalable and can be revisioned in seconds across essentially the different states. So if I go back to my Azure environment, and previously I was looking at my replicate globally, okay? I now have write region and a read region, and I can turn on multi-region writes if I wanted to do that now. I've got the ability to do that on that. Okay, excuse me. Time's up, you can all leave now. We're taking a 15-minute break, by the way. If you have questions, come up and chat. And hopefully I'll see you guys. If you don't want to, if you'll say exactly what you want to say, we will start again in 15 minutes. If you want to go to another session, feel free to do that. If you want to grab a card, they're on the end of the desk here. And hopefully I'll see you after the session for the next piece. If not, it was good to have you. I'm back. They're not. Well, a few of you turned up. Maybe they're going for coffee. Okay, well, let's do part 2. So part 2 is more focused on, we have our Cosmos DB. It's up and running. It's not quite performing exactly as I want it to, or it's costing me too much money to do the performance characteristics I need. How do I fix that? What can I do? How do I capture the metrics I need in order to understand, am I doing things efficiently? So we're going to look at understanding what metrics we can gather through the SDK and through the portal and through our queries, and also some other resources as well, to understand what the RU cost is of our query. The amount of RUs it's going to cost is dependent on essentially a couple of factors. The one is it a read operation? Is it a write operation? They have different cost perspective. How big is the document? But the important one is, what partitioning key have I used, and am I got the right indexing in place? Now remember, by default, we index every single thing that comes through the door. We want to know about everything. We're going to capture that. We're going to have that information. And it's pretty much going to be there and then as we do it. So as that new document is in, we have that in our index. So we can query it quite quickly. So we're going to go through and look at how we look at performance and troubleshooting of the query performance itself. So first off, what I need to understand is, where am I? Well, I'm in Seattle. So I'm going to be in one of the data centers that's close to that. That's great. I can run my query from my application, goes to Cosmos DB, goes to the endpoint, gets the information, comes back nice and fast. Let's say I go on a trip abroad. I go back to my UK, and my data center's here in Seattle or close to it. I run my same query. I've got an additional time lapse that's going to occur because of line of sight and speed of light. So this is where actually turning on additional geographical locations and putting the data closest to where you need to be is going to be important if you need to have that really high performance. Concurrency model. Which one did I choose? Strong, bounded staleness, session, consistent prefix, or eventual. Has some difference in characteristics there. I'm going to show you that a little bit in the portal very quickly. So I go to my portal, jump in here. Now, if I want to go and look at my consistency levels, one, I can see actually what my consistency is. So in this case, my default is session. That's what I have turned on. I need to understand what the difference is for the others. I could go and choose, say, the consistent prefix. I've now got a bit of a replay in terms of the music notes to show me the latency and how these kind of affect. It can make a difference, okay? So be aware of that. Remember now, I also have 2 data centers. One's a read and one's a write. My writes are only in West US 2. If I'm in the UK and I'm doing a write, I've got a bigger jump to make to my data center to write it, okay? If I'm reading, when I contact my endpoint, it goes, which is the most locally positioned one for me? Oh, the one over here in the East Coast. It's a bit closer than the West Coast one, but it's still not in Europe. So you know what I probably want to do at that point as I'm going, yeah, that's not really working for me. I'm in the UK now. Okay, so what I want to do here is I'm going to go to my replicate geographical location. And I'm going to pick the one in Europe. And I'm going to go click on that. UK South, that one looks pretty good for my location. I live in London, by the way, so that's going to be kind of on my doorstep. Okay, click Save. It's doing its thing behind the scenes now. As soon as that's provisioned, if I run my query, it's like, 500 milliseconds, 500 milliseconds. Oh, now I'm in the East Coast, 300 milliseconds, 300 milliseconds. And now in the UK, 4 milliseconds, 4 milliseconds. Makes a big difference. in terms of where you're going to be, in terms of the characteristics, okay? This won't take very long. But what I also could do is say, where's my write? And my write at the moment is West US 2. And because of that, if I'm writing from the UK, I've got to get all the way over to the West US, write it, and get my response. Now, if I'm doing a few writes, that's fine. If my reads is the performance characteristic I need, great, good. If it's the writes, it's going to be, maybe I want multi-master at that point, okay? So be aware of that kind of that information. Okay. We can get a bunch of log metrics by querying essentially what's happening with the PaaS or platform as a service. The log metrics we can put into our log analytics workspace, and we can go and query that later on. We have code, got examples. I think I have, let me have a quick look if I got it in here. I know I've got the query in here somewhere, the screenshot rather. One I did earlier. Oh, sorry, went the wrong way. Queries, there we go. Here's an example of me. I ran a query. It did a scan. It didn't use an index. I can tell it didn't use an index because if I look down, it says index utilization. The fifth one down says 0%. That's not a very high percent. It read 60-odd thousand documents for whatever, was that 4 gig? I can't kind of tell from the side here. It took 4.5 seconds to process, but it used nearly 4,000, or just over 4,000 RUs. Yeah, not a good query because there's no index, okay? It took 4.5 seconds. That's not my single millisecond digit, is it? No way. Okay. Reason being, it doesn't use an index. We actually use an example here where we took the indexing policy, we changed it, we had a value, in this case, upper C description. It's performing essentially like SQL Server does, it's performing essentially an equality check on an index that basically isn't the value. When I write this document, I need to write it in uppercase and remove the word upper from my query. Then it's down to about 4 milliseconds to read it. And it doesn't take 4,000 RUs, it takes about 3 or 4 RUs to do the process. This is where you have the problem. We need to capture these metrics. We do that in the code or SDK or the log analytics, and we actually understand what the characteristics are. But I could just go and take this query and just dump it into my Data Explorer and run the query, and I just look at the extra pane that says how much it costs, and I can see how much it is, and there we go. I won't get all this information, but I'll get the RU cost, and I know it took 4.5 seconds. Okay. So we need to define our queries to be efficient, and if we're using things like uppercasing and stuff like that, we need to write it in that format so the index gets written with uppercase. It's case sensitive in terms of its indexing. It's also ascending and descending sensitive, so kind of the order of the index will make a difference as well, okay? All right. Okay, so let's go back to where we were. Sorry, just troubleshooting. So here we go, okay. This one. So order buys, joins, system functions, group buys have just been introduced, so that will help it, and aggregations will be improved and now. So there's a whole bunch of reasons, but essentially we need to work out what a query is and get it nice and fast. We have some performance tuning. We do that with SQL a lot. We need to do this with this one as well, okay? How do I inform the improvements of my Cosmos DB? There's a few steps. It's not quite do some indexing and look at your query plans and figure out how you change things. This is a different engine, has a different set of performance characteristics you need to work out, okay? First off, networking. If you're using an SDK, use direct connection mode. It's got some underlying kind of characteristics that make it much better performance-wise if you're using direct connection mode. Okay. Use the open async method for being able to call your documents and then use the continuation tokens that exist in order to go and get your data. Make sure your data and your client, if you can, is in the same data center. If not, your performance is going to be less than optimum. Okay. Look at the number of threads and tasks you're going to run. So kind of, you need to provision the kind of parallelism that you're going to do, essentially run this for. There's a few other kind of pieces on the networking side that we want to do, but essentially we want to make sure we're using best practices around that networking side. Which SDK I have? Make sure you use the most recent one. Bunch of performance tuning that goes into those as they go, so it gets better with essentially the way it handles the memory sets, etc. Maximum degree of parallelism. It still exists in Cosmos DB the same as it does in SQL. You've got to tune for that. You've got to set that value, okay? And there's something called a singleton Cosmos DB client. You want to make use of that. That's a better client than the others that we could use. Make sure you use that if you have the ability to use a single Cosmos DB client, okay? For the life of your application. So you go and connect, you set your client up. I can show you some code that does this and basically does its communication and does everything. That's the best one for us to use. It's easiest to set up, okay? Oh, and your item count, you want to buffer some of the values you have. So take the first 100 rows, for example. Cosmos DB by default gives you 100. If you've got 10 million documents, I say select all from the collection. It's not going to give me 10 million documents like SQL will. SQL goes, 10 million? Okay, I'll be back. And it goes off and gets them and comes back. There's your 10 million. Oh, and you wanted the first 10. Cosmos DB will give you 100 unless you ask more. If you ask for next, continuation token, it gets the next 100, 101 to 200, 301 to 300, etc. Okay, those. Part 2. So SDK, make sure you got the latest one, as I said. There's a few bits that we need to do inside of this that kind of will help. Specifically, I'm just trying to remember what they are for this stage. Retry policies and stuff. So there's a rate limited. If you have your RUs that are set to say 1,000 and you bunch a ton of queries against it, you're basically going to hit that 1,000 really quickly. Okay, you're going to get rate limited. You're going to get a 429 error. Make sure that essentially you're doing this so you get back off happening inside of your application code and these kind of things. Excuse me. You've got server-side garbage control as well that needs to be kind of set up, so you do a bit of cleanup with your C# code, etc. We can turn that on. So these are some best practices. There's some more details around these. Tune your page size for queries, read performance for, read feeds for, this one, I remember this one, okay. So when you're reading those pages of data, you want to kind of optimize that for the number of documents you want to come back that your application is going to process. What are you trying to do with those documents? You're just going to showcase them, you're going to put them into a browser, you're going to put them to an application where you want to process the data some way, perform analytics on it. So you've got some values you can adjust around the item buffer count and what the max values need to be. There's also a header information we can actually set as well to say what that needs to be. Up to 1,000 documents at a time, we can set the header that we send saying no more than 1,000, please, and that's our limit, like top 1,000 essentially. So when you're doing your troubleshooting, essentially, for some reason that went out of order, I don't know. We'll come back to that in a sec. When you're doing your performance, one of the first things you want to do is saying, do I need to index everything? By default, we index every single thing. and we may have our exclude pathway just be the E tag, which is by default what we normally have. I'll show you this in a sec. Including paths will be consistent and always on, so we essentially, as a document arrives, index it. Want to query? Great, I've got my index up to date. But that's going to have a cost. The write will take you a little bit more time, maybe another millisecond or two, because it's going to index everything. But you will also have a higher RU. Now, if you don't need to index everything, because you know what my queries, when I run them, it select these columns from the collection, and I'm looking for this property. Well, let me just index some of the key columns and these 4 properties, not the other 30. Because I never filter for them. I never look for those specifically. But that's going to make that document a lot faster to throw the query in, write it, and then when I want to read it, you know what? I've got a smaller index to go and converse across. Because it's more efficient. If the index is smaller, it means I can get that index traversed a lot quicker. And I can update the index much faster, which means it's quicker. So everything kind of wins. But when I want to when I want to query where I've turned off indexing for certain properties, that's when my problem hits. Yeah, because essentially it's then going to scan the table. And if you've got 250 million rows in the table, or documents, I should say, not rows, documents, depends on if it's a table storage API, it will be rows, but items or documents, that can be expensive. There is some efficiencies around that a little bit. Keep some metadata, but it doesn't index everything. Okay. Rate limiting. How close to the kind of curve can I get? So if I'm getting a ton of rate limited 429 errors, and I can see that in the portal all the time, I'm cutting it a bit too close. I need a bit more revisions. But if I get like one every now and then, yeah, that's cool, that's fine, no worries. So look at your rate limiting and see if it actually happens, and if it does, maybe add a little bit more to your cost. Go up by 100, 200, whatever it needs to be to make that happen. When you troubleshoot, you're basically analyzing the response in the header that comes back, the HTTP request. Okay, and that will tell me, was it successful? I got a 200 code. Did I get a 429 or 405 or one of the other codes that says, yeah, that didn't really work for me? And the server may be offline for some reason. That connection may be not workable, not connectable. So we need a client error. Yeah, you've asked for too many. Here's a 429. Or here's a 50, 510. I'm not available for communicating. Work out what you have, and then you need your code to essentially do stuff. Now, if you've got multi-region, if you're getting some of the ones where it's like server errors, it goes, actually, no, that's not working. So you'll go to that one over there, and it will go to the other one, okay? So there's some internal handling of some of the errors, but you're going to analyze your HTTP responses, and you're probably going to put those in your analytic workspace. Okay, so here's some of the things that we have for the SQL API itself. Remember, there's different APIs, so different languages have different codes. So basically, the 400 would be essentially the retry ones. The 500s is basically we got a transport error. We can't communicate on HTTP protocols. And other APIs may have different codes. Depends on the API you're using, depends on what codes you're going to set up there. But how do I do this? How do I monitor what's happening? Well, where am I doing the monitoring from? Is it from the client, or is it from the server? Is it the server side or client server? And I'm going to maybe use Azure Monitor or some application code in .NET SDK to do this. Here's your basic codes. I was trying to remember all these codes off by heart, but yeah, I'm old. My brain's got like an 8K memory socket in there. So have them written down. You can go and look them up. But essentially, these are the key ones. And 429, too many requests. Yeah, you come to the table too many times. We're full. We have every seat taken, as you can see. We don't have too many requests with 429s here. But what we might have is essentially things like entity too large or those errors, a conflict error maybe. Okay. But it's all in the response header, and there's some additional information. You don't need to know about this right now, but essentially, these are the things also that come back in the header that you might be responsible for. Okay. The main one there is the session token and the continuation token as well. Those two are essentially, I've got 100 documents, good, okay, but I've also got more. Do you want more? And the continuation token will allow me to go and grab another 100, okay? Or whatever the numbers are, okay? If you want to find rate limiting, you can do it through code. We can also do it very simply either through your portal as well, okay? So go to Overview. I'm going to go to this one here, 429. I do not have any 429s, okay? No, but if I've seen a number there, and I've got different historical 7 days, 24 hours, that kind of stuff, I can look back. I can also capture this and get that and look at the more informational details. If I go straight down to the bottom and go to my metrics here, I've got the ability to see more information, but I've also got these additional sections. Oh, always happens to it. Let me try again. Okay. Okay. And is it that one? There we go. Okay. I've got different tabs at the top there. I can jump through those and I can understand my metrics better. So throughput, overview, how many IUs I'm doing. But additional, I can see traffic in terms of I've got 2 blue and I've got my writes, okay? So am I having issues with which data center is it happening in? I can do my drop down and say, okay, give me my metrics, but show me it for my issue S. Okay, so I can filter into these areas and get more information if one data center is causing me a bit of grief, okay? But if I go through these others, here's my 429, and I've got some numbers here, actually. Number of requests with 429, 500, 503. I've got information. I can go and see if this collection is having a bit of a bad day or not, okay? All right. But again, I have some numbers at the bottom. I can download a CSV, so if I'm doing my analysis, I can download this and maybe throw it into a Power BI report or something like that. Maybe kind of gives me a bit more of a perspective about what's happening. Good. Let's go back a level and go to, metrics again. So I've got stuff around my storage, my containers. I can do availability, SLAs. I can look at over different ones. I can even customize the time frame as well. Latency, very important one to understand. Am I breaching my latency? What's my throughput? Is it 2 milliseconds? Is it 5 milliseconds? So I can understand if I'm getting good or bad characteristics in terms of my latencies for reads and writes here. Okay. Very important to know if I'm going to need to change something. Consistency. That again is kind of the latency between different data centers. And there's some system stuff as well. So if I go back to consistency rather, you see I've got one between West US and East US, and one between West US and South. Left-hand side is my write, right-hand side is my read. So I've got essentially two paths. One may be performing well, one may not be. There could be something to do with the actual pipelines that we're running our internet traffic on, that kind of stuff. Okay. Okay, won't need to come into that for now. Yes, please.
In your application, right, in your design application, you have this many data centers. Let's assume you have 3 now.
Mm-hmm.
West, East, and UK. How do you determine which data center am I hitting to these?
Mm-hmm. Good question. So the question is, I'm running a query. How do I know? You don't. Don't. Okay. Let me just zoom out of this for a second. Okay. Right. Okay. So we've got our 3 regions. Okay. If it's a write, I know it's going to 1. Okay. It's going to the, yeah. But if it's a read, it's a calculation dependent on the load balancer that basically is the endpoint that you're connecting to, which is one for your own account, for that whole database, okay? Sorry, I'll say it again, for the account. So when I provision the account, I'll show you the URI, that allows me to say, this is my connection. Here's my user credentials, here's my tokens, or whatever there might be, connect. It knows, based on a bunch of metrics going on under the covers, where to send that traffic to. Oh, actually, you know what? Although it's maybe further away, I might want to send the query here because that one has got a load of 429 securing on it. Okay, so you would never know where that query is actually being serviced. Okay, most likely it's going to be the closest one, but you will probably be able to tell by logging the metrics of where it's going to and back that it basically went to East US or West US or UK South, where it is. But at the end of the day, you don't get to determine where it goes. You can call like, it happened, it went there, this is the query, here's my response. But you won't manage that. That's kind of done by the replication. And the consistency model could affect which one you're going to based on the replication state of where data is. There's some factors around that, so, okay. But yeah, you won't necessarily need to or be concerned with where did it go? Because to be honest, it went to one of the first one, the fastest one it could go to. Even if there was a metric to kind of define where it is, it basically, if I ran that query now, it went East US. Run it now, oh, UK South. Run it now, UK South. Run it now, UK South. Oh, East West, West US.
Because like this, you can kind of determine, okay, if my east, let's say, my east is kind of hitting 77%, and the UK is hitting only 30%, then why use the UK? Just kill it. Go to the
So you want to cap metrics from all your locations. I mean, generally, the reason why you're probably putting in another region is for a couple of reasons. 1, performance. 2, business continuity, DR plans, that kind of. So generally, you're pushing it closer because you don't want that long duration of going kind of overseas to go and get your data. Okay. So that's kind of where you would normally think. Here, you kind of don't really need to worry about it. It's like, I've run my query. So this is where you get the, this essentially is the piece of information. If you look at that, it's got the name of the account, in this case, past 2019. And in there, when I connect to that endpoint, I then say, I want this database and this collection when I'm inside it. So it's connecting to like the server. This is my server. I've got everything on there. So that's my connection point. That's my URI, okay? So that's kind of where you're going to get your information from. If I do it in code, essentially, so I can highlight it. There's my endpoint. It's exactly the same one you just looked at, okay? Next piece down is my static read-only string. That's my essentially my access token, or my access key, I should say. And then I've got connect to that, connect with these credentials. That's essentially my account key. And there, below that, I've got essentially, right, here's the database I want to go to. And in there, basically, I was doing some custom index policies there when I wanted to create a new index policy. But I'm connected to the endpoint, and I'm saying, and then this database. Think about you connect to master, and then you're going to use a different database in SQL. Similar thing. Okay. But that endpoint is basically a uniquely global identification. So when you type it, it checks to see if it can use that. Oh, somebody else has got that one. When I came in here, I wanted Cosmos Lab 6161. No one was using that. But I was like maybe typing my own one. I came across one that was actually being used by somebody else. So I had to put an extra couple of numbers on the end or something to distinguish. It's globally unique at that point. That URL can be addressed anywhere in the world, and I know which server I'm going to, and I know where that's hosted, which data center it's in. That's all under the covers. But essentially, I've now got 3 different regions that have the exact same database that's replicated. And Cosmos goes, oh yeah, this is the closest one, go there. Unless it's all right, it has to go over there. Okay. So I was running the code. I kind of did some code. I set it up, the database, through some PowerShell, spin up the collection. Took a few minutes, spun it up, and then basically I've got that provisioned in WestUS. And this was these were the bits that it kind of came back with. So don't really too much about kind of what's on here, but essentially this is how that one got, these couple of databases got provisioned through a PowerShell script using some PowerShell language just to say, right, create this Cosmos DB with this account, this setting, and put it in 2 locations or 1 location or however many I want it to be. Okay. What time do we have? Okay, 45 minutes. Okay. Let's go back to here. We're going to jump on to another topic now. I'm going to kind of end this one very quickly. Essentially, we'll log in a bunch of information. We'll get in that diagnose. We're going to see what failed, what succeeded, what the performance characteristics were, and we can go and view that in log analytics later on. We'll do this one quickly, and then we'll come back to some examples of queries. I wanted to kind of go through these and then come to the queries and see what have questions. It's much lighter than I thought, so we'll be able to get through this a little quicker. How do I learn all this? Coming to a session like this is great, but you're only going to get an hour, 2 hours, whatever, worth of input. So we have some labs or workshops that are being provisioned by Microsoft and some other folks that allow you to kind of walk through the material that you've been looking at and build those databases and build the .SDK examples and do all that stuff. Cool. So you can kind of build these very straightforward, doesn't take too much time. If you don't have a Cosmos DB account, go to Cosmos DB and sign up for their free 30-day trial. Only problem, it's limited to 400 RUs and 1 gig of data, I think. So that, not massive. It's basically a little sandbox they give you free. You can also use the emulator and run all the same code that's in here against the emulator, but using your own computer's resources. So there's some limit. And things like Geographical, turn on that data center, turn on that one. Of course, it's not going to work in the emulator. There's certain things that you're restricted to on that, okay? But you have some good labs here. I'm just going to bring them up on the other screen. A little bit easier to see them. Okay. Here we go. Okay, so this is the lab workshop that you essentially go to. It's cosmosdb.github.io.labs, okay? Or /labs. It has all the PowerPoint decks, it has all the instructions, and it has everything you need in order to educate yourself with a 2-day worth of content workshop that gives you everything you need. Now, clearly, I can't do all of that in 2.5 hours. I talk fast, but I don't talk that fast. But you basically got the ability to go all these PowerPoint decks, and then, if I scroll, you essentially have all these labs. It takes you about an hour to provision it up in pre-lab 1. So run it, run some scripts, it creates the accounts, it does everything you need. And essentially then you'll be able to perform these 10 different labs. Do that. By the way, if you ever do this, that step at the bottom, post-lab cleanup, make sure you run that, because otherwise you'll be spending money. And you'll be not happy when you get that bill at the end of the day if you've left these things on. Some of these get set up with like 10,000 RUs, for example, just to show stuff. Well, that's going to burn a couple of bucks or $10 a day or 15. So if you run these things and you spin the numbers up, just make sure you clean up afterwards. At least take it down to 400 and just have a couple of bucks a day per collection spinning in the background. That's not going to be too traumatic then. You have some Java labs as well. So you've got a bunch of labs on there. Okay. There's some additional labs you can do with the Cosmos DB materialized views. There's about 8 or 9 different main labs out there that you can make use of. Okay. The main thing also, I'm going to show you the Cosmic Notes and where you can access those, because they're very useful to get that high level first image of where you're going with things. So here's Cosmic Notes. Again, it's in GitHub. Let me show you a couple of examples. So if I click on them, they will go kind of full screen. So let me zoom in a little bit. There we go, back to 100. So click back to 100. Okay. So if you go through those, they have some nice little takeaways. They're kind of nicely, there's 85 different Cosmic Notes out there. They did a run of them and then basically stopped at 85. I think they kind of went off and did some other stuff. But they're great ways of just kind of getting some high level information. By the way, every single one of these is in the slide deck. The slide deck has 240 odd slides in it. So what I've done is I've built a slide deck for my workshops and stuff, and I'm basically making use of some of those in this session, okay? But it's a great way of kind of understanding. I'm going to show you some examples of those just quickly. So let me just go to my Cosmic Notes. Again, I've got the where they are, and I'm just going to zoom through a couple of these just quickly. So we were talking about request units. It explains it in a maybe an understandable way, or just helping you explain. Oh, I see what he means now. So you look at some of these, and it will help you understand some of what's there. So just clicking through a few of those just to show you kind of there. But if I click through, there's actually 85 of these things. So if I click through a whole bunch of them, get to some other stuff I've not shown you. Time to live. We talked briefly on that earlier about kind of forcing a value on a database or container level, or individually on a document level you need to, about how long that document should be active for. And when it's basically inactive, or when it's kind of elapsed its time period, it basically can't be purged at the end by the system at some point. Like databases in SQL Server, what we have is things called like unique key constraints that help with understanding the uniqueness of our documents, so we can have some kind of schema stability applied to what we're doing. There's other things like optimistic concurrency control we want to do. So there's a ton of different things in here that will help. You've seen a few of these here. But go through and have a look. If you want to use the emulator, there's some examples about how to use the emulator, how to start making use of these metrics and debug that. How to do a whole bunch of kind of monitoring with the product and Azure Monitor and turn that stuff on. So it depends on what you're trying to do, is going to be maybe explained in some conceptual way with some of these notes. So have a look through. Recommend you kind of spend a bit of time just viewing them and see what's in there, and then research what you have. What you then want to do is, once you have something you need to know a bit better information about, is you're going to basically go to, and I'm just going to show you a trip here, go to Azure Cosmos DB. One, you've got some really nice entry points for stuff, but right down the bottom here, you've got download PDF. What that will do is create a PDF of all the Azure documentation in its entirety. About 4,000 pages, I think, something like that, of this thing. So, right when you're kind of, oh, I just want to look at that, and then, is it a PDF? I can run searches on it. I can search for pages of information. So I'm not trying to click, just trying to, I've got a document I can search. Awesome. So if I kind of want to do that, and I did one earlier, I kind of downloaded the PDF. It won't take too long. It's actually just, I'm just going to let it run in the background for a second. I've got a nice Wi-Fi hard link here. This will take about 2 or 3 minutes to spin up. You save it locally, job done. You've now got documentation. You're probably going to have to update this at some point later on, okay. But you go look for books on Cosmos DB. There's a couple of entry-level books out there. Doesn't really do too much. I'm in the process of talking to A-Press about writing a performance tuning kind of characteristics. But here's the PDF now. We've actually only, it's only about 1,000 pages there. But what I'm going to do is just save that as a PDF. And that will be about 46 meg. Great. We're going to throw that into my local machine. Excuse me. I've got a document now I can make use of. Okay. So great training resources, completely free. Okay. But there's more training resources. I'm in the process at the moment of doing, just kind of let you know, and these are at the moment in-person training workshops in the UK only, but I'm going to record this one for the next time I do the delivery and have the video available to be downloaded for free. So these workshops are free. We go along and we do a one-day workshop on the Cosmos DB. It's pretty much the same level you had, but we've actually built some of the labs. We put some data into it, run some queries, okay? If you want to understand queries and how to run them and how to define them, we have the playground. Now, you'll notice if you look at this one, it's got the old Document DB SQL demo. Cosmos DB came from the SQL, from the Document DB world. But essentially, it's okay. It allows you to run a few queries, understand the syntax a bit. You can kind of work out how to put filtering in and stuff. So if you're really trying to get to grips with the basics of the code, of the query rather, here's an example. We'll just run that one there. And I got my result. And I can see the documents itself. I go into more complicated versions with filters in play. So manufacturer is the Coca-Cola company and food version is greater than 0. I run that query and essentially that one's going to get me some information. Okay. So I've got more information. I've got 7 documents coming back on this one. I can iterate through those documents. So this page is essentially, there's a Cosmos DB database behind it. They created a quick user interface that allows us to do that. We have something called Data Explorer or Cosmos Explorer that's actually a way of getting the data. You can query your own data. So what we can do is here we've got it listed. I'm just going to show you how I got there. I'm going to go back to my overview page. And here on the left-hand pane, we've got Data Explorer. Okay. If I go into that section, I can run my queries directly in here. Okay. But we had a new announcement as well with Cosmos DB on Monday from Ignite, and I think in the keynote here, Jupyter Notebooks. We can now integrate Jupyter Notebooks. Look on the screen, you'll see some notebooks here, okay? And what can we do with notebooks? Well, what we can do is provide a combination of both queries, actions, statements, etc., and instructions through our read-up, okay? So here, I'm going to understand how to use my Jupyter Notebook here about, there's some sample ones there, indexing. I'm going to click on the run. It's doing its thing. That's run, okay? I can see that we've created a database and a container. I'm going to import some documents here. And we can see that we've got our documents being ingested. So wait for that to finish. And it's only 10,000, so it's not going to take too long. It's going to get there in a minute or so. Okay. But if I had a larger RU, I could punch that through a bit quicker. Yeah. Remember, the amount of RUs I provisioned will actually determine how much I've actually going to process. Okay. Come back to that one in a second. While it's doing that one, I can't do anything else. This is the one limitation at the moment about notebooks that's a problem. Is essentially, so if I run that, the previous cell is active, which means I can't go to the next cell until that one's finished. Now I can stop it partway through, but and then I go to the next cell and row. So notebooks, remember, kind of is like run this. It's like query analyzer, query management studio. If you run something and you want to run the next piece of code, you've got to basically wait for that first piece to finish. Okay, so it's probably nearly there. Let's have a quick look. It's halfway through. That's fine. I'm actually just going to stop it. Okay, I interrupted it. You notice I've got a bit of information now, but let me go to the next one. So what I want to do here, let me just scroll down a little bit, get to the next one. I'm going to test that first query. Okay, so I've got basically a 10 millisecond performance characteristic with 2.85 RUs for that query, okay? So now I can define and test out my queries nicely in a product. A Jupyter Notebook, I can save that and pass that around and have my testing and everything else much easier to identify what I'm doing here. So a nice little training tool now as well. One sec. Disable the index. So I've got a piece of code here that's basically going to change the indexing mode to none. I want to know the performance characteristics of when that happens. So I'll highlight it, run, or click in place. I've updated the policy. I'm now going to run this one. Okay, now, same query. 10 milliseconds is now 33. Not a big difference, 23 milliseconds, but it's a 3 times increase, yep. How many RUs now do I have? Oh, actually, that started going up. Now, I think that's just one query. You multiply that by lots, it's going to be an expensive change. But if I'm not really querying this data set very often, this collection, then maybe that indexing policy of none is a good one for me to use. Because the occasional query here and there, even though it's expensive and takes a few more milliseconds, overall it's the saving by turning off indexing helps me the saving on the one there. But I can test this stuff out. I've got things like my visualizations I can do directly now in here. So let me just double click on visualization here. Oh, there we are. And I'm basically going to do, here we are, run all, just to kind of make it a bit quicker for me to jump through. And it's currently running. At some point it will get to the end of it. See if I can find out where we are. I can see I'm busy, by the way, right at the bottom of the screen. It's like, yeah, I'm busy. Come back in a minute. I can see it's actually running the code. It's doing what it needs to do. When I'm finished, I can come back. I can schedule these. So think of everything you can do with your Cosmos DB that you've essentially been interactively processing. Now you have Jupyter Notebooks. Now you can schedule it. In something like Databricks, which we can also make use of now through the Synapse analytics, we'll be able to have Databricks spun up, a cluster, do its processing, do its analytics, do its workload, and then shut itself back down again. So we've got a whole bunch of stuff we can do that's going to be really easy. So let's see if this is nearly done. Okay. Oh, looks like it had a bit of a... oh, no, so it's running at the moment. We're actually up at this one here. And there we go. I've now got my visualization. All I did was click run all. I created the notebook with all the instructions. This runs against my data set that's in Cosmos DB. Job done, and go home. Previously, I'd probably have to spend some time processing that workload. Now I can kind of automate it and get some. So this is a great new functionality that's been given to us. Okay, but again, you've got some options around which languages you're going to make use of. Look at your different types of cells and stuff you want to do with your notebooks. Okay, let's go back to the main Cosmos DB for now. Okay, so I want to create something new. Okay, I was hoping that would come up at some point. How do I know when things have gone over my limits? I get a nice notification. Yeah, you're pushing the limits here, and it tells me. So here, I now go, okay, great, thank you very much. I now know that this session, specifically this collection, kind of got a bit heavily hit. And my revision was only maybe 400, and maybe I was trying to run a 600 or 800 or 1,000 workload kind of capacity on it. Okay. I can click on the metrics, and it's told me exactly what I was getting and which site it was at and what's the workload. So I do have some cool information coming back from the product to tell me, hey, this is your usage patterns, maybe a little bit over provisions, maybe I need to increase the capacity there. How do I know what the capacity is for that one? Well, there's a couple of things I can do. I can go and look at the individual kind of workloads and see what I was running. But what I can do here is go over to, there's the cursor, okay. I can go and see what I have provisioned on that specific site. And if I need to go and change that, I can go in and go to my scale, pick the specific one I'm interested in. So for example, the retail demo would be one, and take that back to my 400. And I've got my changes made. That's now at 400. So if I had a constant workload hitting that at the moment, and it was like only maybe 20, 30% utilized, and I take that down to 400, I may be underutilized now, or overutilized. So I might start getting my 429. So you might have to adjust things. But if you use autopilot, you don't have to do this. It will basically re-provision the levels for you as it demands, okay? And if I do a new collection, so I can add a new container, and in here, notice I've got two options here, autopilot and manual, yep. Okay, so I go and pick the autopilot. I now have the ability to choose what is the kind of threshold I'm going to go to the maximum for, all right? And it starts off at 4,000 and goes up to 500,000. That'll be a bit of money, that 400,000. Okay. Now, let's say I want to create a brand new Cosmos DB system. I'm going to go to create a resource. I'm going to type Cosmos. There's two options that basically come up here. Oh, there you go over. Okay. Cosmos DB and Cosmos DB reserved capacity. You get to set it when you create the account, and only when you create the account, okay? So if you want reserved, where it's going to cost you a lot less money, but you have to provision for a year or 3 years, you need the reserved capacity, okay? And you need an account subscription that's allowed you to do that. So there might be some restrictions on what type of subscriptions you run. But essentially, in this case, I'm just going to do the basic Cosmos DB here. I'm going to say, okay, Cosmos DB. And I'll get my standard kind of window pane comes up. I'm going to click create. I'm going to show you how quick we do this. You may be aware what a resource group is. If not, wrong one. If not, a resource group literally is a kind of a logical unit that you're going to basically put resources into. It's just like a folder or kind of an account name. I'm going to select the existing one. I'm going to give it account name. So I'm just going to give it my name and see if that's been used. It's got a little tick box to the right-hand side that's green, which means that that is good. This is where you get to choose your API. You choose which one of these you want. That's the type of database you're provisioning. The documents you put in, but then if it's, say, a graph one, I can still create it with SQL API. I've got a multi-model, multi-API thing. There's some one ways that works, one ways it doesn't. So, like, for example, the MongoDB is not going to really be good against the graph one, for example. Okay, but also on there, you notice that we had notebooks and none. Okay, so if your account doesn't have notebooks on it and you want it, you come in, you either provision a new account or you go and turn on notebooks in your existing account, and then you've got that notebook functionality. Basically, connecting the dots there. So I'm going to say yes. I'm using the core SQL. I'm going to put it in. Let's say I'm going to put it in West US 2. And for now, I'm just going to go review and create. It's going to validate that it's OK. I've got it in my resource group. I've got my subscription listed. Create. And if we watch it for about 15 seconds, it should create it. We'll see if my timing is good. Yeah, it's not come up yet. Come on. There we go. And this will turn in a second to, OK, it's now provisioned, and you should get a warning coming up saying, oh, you know, go to resource. It's taking a bit longer than I thought it might do. OK. Cool. But this is the wrong way to do it. Okay, so if you're going to just do a quick demo, yeah, sure, this works fine. You want to script your stuff and you want to put it into your source control. So I would generally do mine through VS Code, and I would do it this way. I'm going to show you why this is provisioning up. So essentially, one of the early ones I did was actually, and this is in the instructions, I created a container. So here we're doing some indexing policies, but potentially I was creating the container. If it didn't exist, it would go and create it. And I think if I scroll back through some of these, I've done just that. It's created the database. It's created the databases there, etc. So we'll see. Oh, let's see if that's finished. Okay, seems to be taking much longer than it did earlier, but anyway. This is one thing about Azure, by the way, actually. Sometimes, especially in demos, don't know why, you'll do something that takes like 10 seconds, and do next time it takes 10 seconds. You go to demo, it's like 2 minutes. Like, what the hell? But it's dependent on what's queued in Azure, because this is a shared resource area, and you're going to basically be provisioned on what's actually here. So is it nearly there? No, not quite. Okay. When it does come up, it'll be good. Now, another way of doing your labs and stuff is through PowerShell. And eventually I've got one that's called Lab Setup 1 in this folder. I'm just going to go to the folder. So it's cmaster labsmaster.net. So see why it's doing that, labsmaster.net setup. And in here, essentially, it's a PowerShell script that's going into provision stuff. I create my environments with PowerShell. I create my applications with Visual Studio Code. And I very rarely go into the portal to do anything, unless it's a quick kind of, just a quick demo or something like that. Because I want to be able to repeat this operation every single time. And I'll parameterize regions and stuff like that, so I can kind of put in the value in the PowerShell and actually say which user and I'll type West US, and it will use that, and off we go. Okay, let's get rid of that for a second. So see if we actually have the environment up. Okay, typical, and I knew I should have done this like earlier. So let me go into my home page, go to my Cosmos DB. It's still creating it at the moment. For some reason, that's taking a while. I'll come back to that. Okay. All right. So we went through the Cosmic Notes, went through some of the training resources, some of the workshops. Everything I have is in this deck. This deck will be uploaded. Unfortunately, they do it as an upload in PDF format. Okay. If you want it in PowerPoint format, grab a card, and I will send you the full lab in PowerPoint format. For some reason, past one, oh yeah, it's PDF. It's like, okay, but that's not really, it hasn't got all the notes. I don't give you the note, you don't have the notes when you get the PDF. And there's like 244 slides here, so there's like quite a few, something like that. Okay, generally I was leaving 10, 15 minutes towards the ends for questions, but I'm gonna just click a couple of things here. Okay, is it ready? Let's have a look. Yay, awesome, right, so I've got an account. That's no good to me. I've got nothing in it. I've got no databases, no collections. Okay, so let me create a quick collection. But you notice when I go in here, it goes to this quick start option. If you want to do something, create an account, come to quick start, click on there, and you can create your next steps that you want to do really, really quickly. Okay, so I'm just going to click on that now, and I'm going to create a items container. I'm clicking on the button. It also gives you a download of a sample app for .NET that you can use to get started with all of the stuff you need for that container. Okay? Let me click on that. That's going to create me a quick start one in there. Let's just save that file. Okay, thank you. Okay, let me go to the folder when it's done. Okay, this is a Visual Studio one. I'm going to open that with my Visual Studio application. So, create an account. Click on Get Started. Click on a button. Click the download button. I'm so lazy. I believe it was like 2 clicks, 3 clicks on there. This is downloading now, and it's going to tell me we're not loaded. Yeah, pain in the ass. That's why I don't like Visual Studio. I like code, not Visual Studio. There was some issue with the project folder type. So, because I think I've got code on this machine as well as Visual Studio, it goes, yeah, I don't like you now, and like it breaks it. But what I can do is go into the folder. I go into the source folder, and I go to my application. But I've got everything I need in here, that what I'm trying to do. So I'll probably, what sometimes do is I go to the folder that I need. I see what the problem is. It's not extracted. I do this every time. Because a folder to me looks like it's a folder, but it's got a zip thing on the side. Okay, now I have the folder. Okay. Right click, do open with code. I'm basically going to open a terminal window and type a couple of things. So I just want to go here. That's later, thank you very much. Open a terminal window. It's now in the directory I'm here. So .NET build. Oh, I need to run it first, sorry. Let's get rid of that out of the way. Come here. Can't remember the command. It's not run. I'll remember the command later. That will usually create a project. Create console, something like that. I'll work out what it is. I usually write it down. That will create an application with a program.cs and everything else. And essentially, I've got all that to run at that point. I haven't got my glasses, so I can't see what that says. But generally, I'll then have my Visual Studio Code project with everything I need, and I can then go into that. So it will look like the one I created earlier, like in blue pizza fashion. If I go to my Visual Studio Code, let's kill this one. So this one here with the program CS, I'm just going to see what I actually ran to start with. .NET build, no, I've already done that. Okay. There was something else I missed somewhere. Okay. Oh, I haven't got the libraries. I haven't got the .core libraries installed. That's all right, I'll do that later. But you can build your container really quickly with that. But if that fails on you, for whatever reason, like you're doing a demo, you can go and create it in the service. So I'm going to go back to, yeah, and if I go to Open Data Explorer, what I have is no data. I have my collection called data. I have my to-do list, which is, I have a database called data. I have my collection called to-do list. I got no data in it. It's an empty table, empty collection, I should say. So I need to import data. How do I do that? I do it in two different ways. One, I can use code, but otherwise I can go, oh, you know what, I just need to load some data. Okay, so where will I do it? Well, there's a little upload the button item here. You click on that. It's literally going to go and say, where's your files? So I'm just going to go into that one there. So we've got some files in here. Okay, so anyway, I'm just going to pick these files. Upload. Oh, there's some size limits. Let me just see what we have from a size perspective. Okay, let me take that one, and that one then. Come on, why is it not? Oh, 2 meg, sorry. Yeah, I thought it was 20 meg for some reason. My head, let me try that again. So 2 meg. I was trying to, so let me do one. So that one, and that one. Nope. They're not, that's less than 2 meg though. Am I not right? Okay. Let me try one at a time. Oh, that's 4 meg, isn't it? So, okay. Right, okay. So, limitation, really, really small limits on that upload button sucks, okay? We have a whole bunch of ways of getting the data in. The way I normally do it, if I've got a large number or folder, is I use ADF, Azure Data Factory. And I create connection to my Cosmos DB container, and I create connection to my source file, which is my folder, and go run. And off it goes. So there's a number of ways we can do it. Generally, I do something like ADF or stuff. I won't really ever use this upload feature because it sucks. Because it's like, oh, yeah, 2 meg is like it's that big, you know, tiny. What I can do though is I can go no item, and I can cheat. Okay, so look, there's my data, new item. Let me go to the document. You don't want to do this one by hand, by the way, obviously, naturally. So I'm going to go to Files. I'm going to pick that large document. Go grab that one. I want to open it with, say, I don't know, let's do Notepad or something. Yeah. It's a JSON document. So Control A, copy it, come over here. Okay, and did it put it all in there? Okay, looks like it's got a bit of a problem with that one. Save. Okay, is this saving? Did it clear everything? Okay. Oh, okay, so it had a bit of an issue here. I've tried some examples like that before. It depends on the size, and it generally tends, if it's not a formed JSON file, when I query, so maybe Notepad's giving me an issue. If I paste it in, it's not an actual form JSON document. It goes a bit mental. The interface is not good. But I'll basically go and grab that document and do something like ADF to import the data. I've got like a couple of minutes left, so I'm not going to do that from there. There's some additional stuff that you will, okay. That one, there we go, okay. When you have Cosmos DB deployed, and you've got your queries running, and you've got your RUs set, and everything's good, and you go, right, okay, I'm done, okay. There's some additional things that we can do that we haven't covered that's going to be in your labs if you want to do them, and they're called store procedures, they're called user-defined functions, and triggers, okay? There's some limitations on some of those items there. So, for example, store procedure is a single partition boundary. There's a new feature or new kind of release, not new, announcement rather, they had on Ignite around a new bulk executor library in the .NET SDK that allows us to basically do things in the bulk mode that we would have used the store procedure for before. Okay, so things like that, okay? Thanks, okay. But this is the one I want to kind of really focus in on. Trigger. And you notice it's got a little kind of lightning strike next to it, okay? What does that mean? What's that lightning strike for? Where else do we see that symbol? Azure functions, yeah. So basically, we're triggering a function. What can we do in a function? Whatever I bloody well like. Basically, as long as I can write the code and get it to function, I can do what I like with that function. This essentially is when a value comes in, something happens to the data, I want to file that trigger, I want to then get that trigger to do a bunch of stuff. And that could be a whole different range of things. But this is a great functionality of data's arrived, data-driven activity based on the trigger that gets fired. I can go to the Azure function and do a bunch of stuff. So if I went into Azure and did some function stuff, then we go function app. Can't do Azure function, doesn't exist. I love it. They have some words that start with Azure and other words that Azure doesn't exist. Depends on how old it is. But you want to build some Azure functions, essentially you're going to have to again kind of start, create some, so Cosmos DB trigger, okay. I'm going to choose this .NET Core. I'm going to choose where I'm going to run it in US, etc. And I'm basically going to create that trigger and have that run. I'm going to, excuse me. I knew I wouldn't last the whole 2.5 hours without losing my voice. That would then be created. And then when that's created, I can then go and bind that function to my Cosmos DB. Maybe the change feed library can, combine it with that, and then basically I can go and perform a bunch of other activities to do what I need to do. There's a whole range of things there that we've not covered. Okay, I've got some policies in place, so they probably stop me doing stuff that I don't really want to do. Okay, we'll come back to that. Let's get rid of that. So let me come back to here for a second and go from slide and just get to the end of these ones here. Go ahead. Mm-hmm. Right. Okay, so the question is, I've got a function, I put it into a certain region, but my databases are spread across multiple regions, okay? So what you probably want to do is co-locate them. So you want to have like that one is bound, that data center in that one, UK South is using this function. The US West is using this function. So I might deploy the function in 3 places. So it's local, just a copy of it, essentially. It's just a piece of code. It's just basically code that's encapsulated. And yeah, just slide it, there we go. It's a piece of code that's encapsulated. So you might have multiples of those. They're pennies. So it's not really, so yeah, but you probably want, you could use a central one and just every single one connects to it. Depends how much data you're processing across the function and what the function is actually doing, whether you actually have it local or a central one. But it's a piece of code, so I just like that and just replicate it around is what I do. Well, thankfully for you guys, this is finished. Hopefully you say, frankly. You may have questions. Hopefully you've enjoyed it to some degree. Hopefully it's been useful in some way. Fortunately I've got an ulcer, so talking's been a bit of a pain for me for the last hour or so. If you like what you saw, survey. If you didn't like what you saw, survey. Basically the answer is you need to survey, please. Let us know. Okay, this is massive room. I have no idea why they put me in there. I think they basically ran out of room in the other rooms. But you might get a prize. But if you got any feedback, feel free to share it. If not, keep it to yourself, whichever. But do a session evaluation. It helps the organisers pass to understand, did you like the session? Was it useful, etc. Yeah, so it's more for them probably than me. If you need to contact me, I'm on Twitter. I've got cards. I'm happy to take questions. I'm going to go to a dinner very quickly with Redgate, and then I'm going to my whiskey meetup. So if you want to go to the whiskey bar, there's 80 of us going. It's going to be fun. I'm not buying around, not for 8 people. But you may convince me you have a really good question. I might buy you one.